Okay, so we are getting down to investment analysis. And in this investment analysis, we are looking at a topic called risk and return. So under this one, we're simply saying that risk is the probability. Okay, so risk is the probability that actual return from an investment, okay, differs from expected return. All right, so this is about what risk entails. So the actual return from an investment differs from expected return, and of course, we know that our expected return of a stock, okay, is equal to, so expected return of a stock is equal to summation of probability, then multiplied by the return. So this is the expected return of a stock. The summation of a probability multiplied by return. And of course, we now look at calculating stock variance. So the stock variance and standard deviation. Okay, so our stock variance, so we are going to have the probability, then we are getting down to return of A minus expected return of a stock, then return of a stock minus expected return of a stock square, then probability return of a stock minus expected return of a stock square. So what we are getting now here, these ones are what we call the variances. So the variance will actually be this value. Now, the standard deviation is the square root of variance. So standard deviation, okay, we'll go to the square root of variance. The higher the standard deviation, means higher risk. Okay. But standard deviation is not good measure of risk, because it ignores the expected return. The good measure of risk is the coefficient of variation calculated by coefficient of variation is equal to standard deviation then over expected return. So standard deviation is the risk and this is the return. Okay. So this is the good measure of risk because it considers both risk and return. Okay. Now, of course, we can get down to calculating covariance of stock. So the covariance exists between two stock returns. So covariance exists between two stock returns. Okay. So for the covariance, we have the table here where we say P return of A minus expected return of A. Then return of B minus expected return of B. Then we have the probability return of A minus expected return of A. Return of B minus expected return of B. So this is on the covariance of stock. So we have the addition of all these will actually imply the covariance. Okay. So the summation of all these ones will give us the covariance. This one, this one, this one will give us a covariance. And of course now, or you can say covariance, okay, is equal to correlation, okay, coefficient of A and B multiplied by standard deviation of A multiplied by standard deviation of B. Then we of course now getting down to calculating what we call the correlation coefficient of two stocks. So correlation coefficient is actually equal to covariance of A and B over the standard deviation of A multiplied by standard deviation of B. And then correlation coefficient shows this one shows the relationship between two variables in order to determine if we have a negative or positive relationship between two stock returns. All right, so this is about what we have concerning the risk and return. Okay. Now, what goes on here is that we need to look at what we call the portfolio management. So portfolio management. Okay. A portfolio is a collection of securities. So a portfolio is simply the collection of securities, and the risk in a portfolio is spread, okay, is spread among the securities. So expected return of a portfolio is actually equal to summation of weight of A multiplied by expected return of A, then plus weight of B multiplied by, okay, multiplied by expected return of B. So this is about a portfolio. The expected, so the expected return of a portfolio is neither higher nor lower than expected return of individual securities. Okay, so this is what goes on as we are looking at this one. Now, portfolio variance. Okay, so variance of a portfolio. So variance of a portfolio is equal to weight of A square multiplied by variance of A plus weight of B square multiplied by variance of B, then plus 2 multiplied by weight of A multiplied by weight of B multiplied by covariance of A, covariance of A and B. So this is about what we have concerning the portfolio variance. This is, of course, this is the portfolio standard deviation. Okay, so the square root, this is the portfolio, okay, portfolio standard deviation. okay, which is given by the square root of weight of A square multiplied by variance of A plus weight of B square multiplied by variance of B plus 2 multiplied by weight of A multiplied by weight of B multiplied by covariance of A and B. So this is the portfolio standard deviation. All right, so this is just about what goes on as we look at risk and return. Okay, and then we can get down to the example here. Okay, from here we can do a random selection of questions from there. Okay, from the questions that we have here, we'll do a random selection of questions. Okay, so we have this one here. Okay, the question for 15 marks, that's question 2 on risk and return relationship. A stockbroker calls you and suggests that you invest in the Bahrain Computer Company. After analyzing the firm's annual report and other material, you believe that the distribution of rates of return as follows: possible rates of return probability. Okay, we have the information here, and then the question is asking us now compute expected return on the Bahrain computer. Okay, so expected return is equal to summation of probability by the return. So under this one, it will actually be negative 0.6 on 0.05, then plus negative 0.3 on 0.2, plus negative 0.1, okay, 0.1 on 0.10, plus 0.2 on 0.3. Then we have the other one plus 0.4 on 0.2 plus 0.8 on 0.15. Okay, so meaning that our expected return of the stock here will be, so we can start computing and see what the answer will be on this one. All right. So here we are getting 0.16 or 16%. So this is the expected return of this given stock. All right. Using the information given here, we must simply multiply the probability by the respective return. So we have the 15 marks on this one. All right. Then we can get down to the other question as we are doing the random selection. We can look at question number 2. Question 2, calculate expected or required rate of return for each of the foreign stocks. Okay, given the risk-free rate, for the risk-free rate is also referred to as treasury bills, government bills, return on the market. So this one is using capital asset pricing model aspect. So for the 15 marks, so for the first one, our formula is KE is equal to RF plus beta, return of the market minus risk-free. So here it will be our KE is actually equal to risk-free rate of interest is 0.08. And we have the beta is 1.72. Then the return of the market is 0.14. Then minus the 0.08. So we can get the value here. For this one, our KE, our risk-free rate is 0.08, then plus 1.14 on 0.14 minus 0.08. We can get the value. Our KE for this other one would be 0.08, then plus 0.76. Okay, on the return of the market is 0.14, then minus the 0.08. Then getting down to the other one, we have our KE actually equal to 0.08 plus the 0.44 on 0.14 minus the 0.08. So getting down to the other one for the other stock, our KE is equal to 0.08 plus 0.03 on 0.14 minus the 0.08. Then here our KE is actually equal to 0.08 plus negative 0.79. All right, then 0.14 minus 0.08. So we can find answers here. So getting down to the first one, we are simply now finding the solution to each of these ones, all right, that we have. So the first one is 0. So each one is 18.32, 18.32%. And then, of course, the other one is giving us 14.84%. Then the other one is giving us, okay, is giving us 12.56%. We have the other one is 12.56%. Then getting down to the other one, okay, the other one is giving us all right. So the other one is giving us 10.64%. So 10.64%. Okay. Of getting down to the other one. All right, we getting down to 8.18%. 8.18%. Then we are getting down to the other one. Okay. It is giving us 3.26%. 3.26%. So here we are also getting down to our 15 marks for this one, for calculating using the capital asset pricing model. So this is capital asset, okay, pricing. We have the pricing model asset here. Okay, so this is on what we are looking at concerning the risk and return. Given the return of the market, RM is the return of the market, or market return of market. And then we have RF is called risk-free rate. Okay, so this is just about what we have concerning the risk and return aspect. Okay, so we can now get down to the other one. Okay, so risk-free rate is 10%. So this is a risk-free rate, 10%. And market return of the market. So this is market return. Okay, so here our expected return for this one is actually going to give us, using this formula, we're still using the same one, risk-free plus beta, return of the market minus risk-free. So our risk-free rate here is 10%. The beta is 0.85. Return of the market is 14% minus 10. We can get the value. For this other one, you're getting 10 plus 1.25 on 14 minus 10. Then this other one also, we have the 10 plus negative 0.2 on 14 minus 10. So we can get the value. So the first one, okay, we are simply getting 13.4%. So this is 13.4%. And then the other one, okay, we are getting 15%. Then this other one, okay. So we have this other one, we are simply getting 9.2%. So this is actually the cost of equity using the capital asset pricing model. All right, so this is what we are getting down. Okay, so now this is about what we have here concerning the information given. Okay, so getting down to the other question here, we are a stockbroker. What the firm's research department expects for the 3 stocks in question. Stockbroker responds with the following information. Okay, so current price, expected price, this is P1, PO, and this is the dividend. So we want to find the holding period return. This one is called holding period return. So the formula for holding period return is equal to, okay, P1 minus PO plus DO over PO. So getting down to the first one, for you, the P1 is 24 minus the PO is 22 plus the dividend, which is 0.75 over 22. You can get the value for this one. Then for N, we're simply saying 51 minus 48, okay, plus the 2 here over 48 we can find the holding period return for each of the stock that we are talking about. And then for D, we are also looking at 40 minus 37 plus the dividend is 1.25, then over 37. So we can get down to the answers here. Okay. So we are getting 12.5% for this one. Then this one is 51 minus 48 plus 2 divided by 48. We are getting the 10.4. So this is 10.4%. The other one is okay, 11.5%. So this is how you are getting down to the holding period return given the information above. All right. So if we are to find the expected beta now, as we are getting down to the information given, we can find the expected beta from the information given in the question. The beta for each of the stocks that we have here. Okay. So before getting down to this, okay, so now we're getting down to question 3. Where it says the following are the historical returns for the telecomputer. So the year 1, 2, 3 up to 5. So if you want to find the probability, you simply say our probability is equal to 1 out of 5, which is 0.2. So the probability is 0.2, 0.2, 0.2, 0.2, 0.2. So these are the probabilities that we are given here. Okay. And then what we need to do now here is that we need to now find the expected return over, okay, the telecomputer and of course the general index. This is just simply the same way we did on these other questions above, on finding the expected returns because the probabilities are given. So it's simply multiplying expected return is equal to summation of probability by the return. Okay. So this is on how this question was supposed to be answered. Okay. So we can end here for now. All right.